We are on Unit 2, Quiz 3, Study Guide question number 12 and question 13. So you are asked to find the domains of question 12 and question 13. So whenever you need to find domain, there are only three cases. The first one, when your function is a fraction, and there's an x value at the fraction. So this means that because a fraction denominator cannot equals to zeros, otherwise your function is undefined at that point. So you want to find out when 3x plus 2 is not equals to 0. So you'll find out that when is it going to equals to 0. So x will equals to 0 when 3x plus 2 will equals to 0 when x is negative 2 over 3. So this is the point where your function is undefined. So when I write the domain, I'll put all value of x such that x cannot equals to negative 2 over 3. Otherwise, your function is undefined. This is the first one. The second one is when you are given a square root. So you have to know that you can find the square root of 4 because it equals to 2. So positive number is defined. Positive number is okay. And also for square root of 0, 0 is okay because square root of 0 is 0. However, when you want to find the square root of negative 4, which is a complex number, you cannot find, just like using your calculator, you cannot find square root of negative 4 because it's undefined. Only if you have, on the real number system is undefined. So that's why negative number is not okay. So that means that 3x plus 2 can only be positive or 0. So in order to express 3x plus 2 is positive or 0, you have to write an inequality. So it will be 3x plus 2 greater than or equals to 0. So I have to solve 3x plus 2 is greater than or equals to 0, so I subtract 2 on both sides, and then it becomes 3x greater than or equals to negative 2. I divide both sides by 3, so x is greater than or less than negative 2 over 3. I'm not changing or switching my inequality sign because I'm not dividing or multiplying negative number. So my inequality sign stays the same. So when I write the domain, it's all value of x such that x is greater than or equals to negative 2 over 3. So this is the second case. And the third case. The third case is where when your square root sign is in the denominator. So whenever I see the square root, I know that it's going to be defined for positive and also 0. However, because it's in the denominator, fraction cannot equal to 0. So I can just make it greater than 0, which is only defined for positive, not equals to 0. So the same thing, I'm going to isolate my x. So I subtract 2, and 3x is greater than negative 2. And then I divide both sides by 3, so x is greater than negative 2 over 3. So that means that my function is defined when x is greater than negative 2 over 3. So my domain is x, or value of x such that x is greater than negative 2 over 3. So this is my domain. So there are only three cases for the domain, otherwise usually the others will be all real numbers. So this is the only one, three cases. And now we are going to go on question 12 and 13. So question 12, my function of x is 7x plus 2. So you ask yourself, is there any number for x that makes this expression undefined? So you also ask yourself, is this in the denominator? No. Is this under the square root? No. So that means that probably no values of x will make this expression undefined. So my answer will be, domain will be all real numbers. That means that x can be any number. Your function will be defined. So in order to write in set theory, so we have all value of x such that x belongs to real numbers. So this is how you write it in a set. This is question number 12, and I'm going to work on question 13. So question 13, So there are two ways to work on question 13. But the first thing you know that f of x equals to square root x squared minus 9x plus 20. So this is an expression under the square root. So I'll have x squared minus 9x plus 20. Because it's under the square root, it's going to be defined on positive number and equals to 0. So I can put it greater than or equals to 0. So after that, I'm going to factorize my quadratic expression using x factor. So I have a is 1 times c 20 on top and negative 9b at the bottom. So you ask yourself, what are two numbers that multiply to be 20 but add up to be negative 9? So you have negative 4 and negative 5. So x minus 4, x minus 5 is greater than or equals to 0. So there are two ways to work for this one. I like using the graph instead of the table, but you can pick and choose which one works for you. If I want to graph it, I want to find out what are my roots, which is x equals to 4 or 5, because I need to use zero product property, ZPP. And then a equals to 1, which is greater than 0, so my graph opens up. So when I graph it, I'll have my x-axis and y-axis, and the roots will be 4 and 5. It opens up, so my graph will cut through these 2 points and opens up. So that means that my graph is having 3 different parts: the first part, the second part, and the third part. So you ask yourself, when is this line, this parabola, above 0? So it's only above 0 for the first one and the third one. The second one is below 0. So the first one is above 0. That means that all values of x, which is less than 4. So this part is x is less than 4. So it's equals to 4 because when it's equals to 4, it's equals to 0. I can equals to 0, so I can put x less than or equals to 4. And the third part is greater than 0, so these are all values of x such that x is greater than 5. So I can put x is greater than 5. When x is equals to 5, your graph equals to 0 is at this point. So I can put the equal sign here too. So my domain will be x such that x is less than equals to 4, or x is greater than or equals to 5. So this is one way to work it out. Another method to work it out, I'm going to use a table. So I'm going to set up my table. So there are 5 columns and you will need 4 rows. 5 columns and 4 rows. So I'm going to look into this part. So I want to test if this one, which interval will give me my inequality greater than or equals to 0. So you're going to put your interval inequality here, the first column. The second column will be the test value. The third one will be, you want to test out x minus 4, is it going to be positive or negative? And then you're going to test x minus 5, is it positive or negative? And you want to find out, is it really greater than or equals to 0? So the first interval, so you'll have the roots positive 4 and positive 5. So this is the first interval, second interval, and the third interval. Any value that is smaller than 4, less than 4, is equal to, because I can equals to 0. And then in between is between 4 and 5. So I will write my interval like this. And the last one is any numbers that is greater than 5. So I can put my interval like this. I have the equal sign because it can equals to 0. So I'm going to test. I can find any numbers that is less than or equals to 4. I'm not going to choose my boundary 4 because it's going to be an ambiguous case. That means that 4 can be tested here and tested in the second one, so you are not going to use those numbers. So I'm going to use 3 for this one. And then x minus 4, that means that when 3 minus 4 is going to give you negative. And also 3 minus 5, you are going to have negative. So negative times negative will give you positive number. Positive number is greater than or equals to 0, so this is a check. That means that this interval is correct. And then, so in between 4 and 5, I'll choose 4.5 because I don't want to choose 4 or 5, which is ambiguous. So 4.5 minus 4 is going to give you a positive number. 4.5 minus 5 is going to give you a negative number. When they multiply, are they going to be greater than or equals to 0? No, because positive times negative is not it's negative. Negative is less than 0. And the last one, instead of choosing 5, I will choose 6. 6 minus 4 is positive. 6 minus 5 is positive. Positive times positive will give you positive, which is greater than or equals to 0. So my first and the third interval is correct. I'm writing the same domain because they are the same. Using different methods, graphing or tables, they will give you the same domain. So this is my answer.